So first things first, are there any homework questions or lab questions? No? Okay. So we're going to kind of look at the quiz today. And then I want to talk to you guys about, it's really important that you have good working groups, right? Because really, there's only one of me, and there's many, many of you. So the people who you're working with is where you're going to get primarily most of your help from. Your classmates around you in your kind of your larger area, or your smaller area. So make sure that make sure you make use of the folks around you. If you guys want to move after the exam, the first exam, feel free to move around a little bit more if you want to. And also be resilient. So I think I talked to you guys a little bit about how AB 705 has affected things so people can come straight into this class instead of taking the prereqs beforehand, which means that the whole idea is they kind of are anticipating people may not pass the first time, but they'll do better the second time if they failed the first time than it would be if they had taken Math 50 the first time and then taken statistics. So that's kind of their plan, is take this twice and hopefully pass the second time versus take a prereq and then take this. So it's all new material. It's all kind of different things that you aren't used to, so it might be overwhelming. Stay with it, be resilient, keep coming, and hopefully you pass this time. If you don't, that's okay, because it'll put you in a good position to pass the next time. So just don't give up. All right, keep working at it. All right, so then let's talk a little bit about what we're going to do today is reviewing for the exam. You have 4.4 Connect Math due today. Do not, I'm going to say this one more time, do not use the help buttons for 4.4. This section, it will confuse you more than it will help you. So that's not true for most of the book, but the 4.4, just do it my way, and don't use your help buttons or the show me an example. Because I think the way they do it is just going to make you memorize formulas, and it's not about memorizing formulas. Right? Math should be about teaching how to think logically, because which is a more useful skill for you in the real world? Thinking logically or memorizing formulas? Thinking logically. That's why we force you to take math, so you can learn to think logically. Okay. Project Part 2A, we took pictures. You guys are good with that. Part 2B is due next Thursday after the exam, and it's just basically cleaning up the data. So I will try to go over that a little bit in a minute. Make sure it's on. And what you need to do with that one. The exam is going to be next Tuesday in here. I will have an office. My office hours on Monday, I'm going to move those around, so I'm going to be doing review sessions instead in 600, right across the way, from 3 to 4 and from 7 to 8. So come to either or both. Exam 1 is going to cover chapters 1, 2, and 4. You should bring these things, a pencil, half-page, one-sided of notes, handwritten by you, scratch paper, and a basic calculator. Even if you have a fancy calculator, you have to write the formulas. Blank times blank times blank times blank divided by blank for 4.4. I don't want to see this factorial divided by that factorial. I want to see the actual numbers that you multiply and the numbers you divided by. That's what I want to see. If you want full credit. If not, then if you're fine with half credit, then that's okay. But half credit is, on those 20 points, it's like 10 points maybe, right? You also need to bring your binder in order if you want extra credit. For that, you also get credit for 2 smart shops, 1.5 point each. You bring the little slips showing that you attended and you were there. I take them, I tear them up, and I give you a point on your exam, or half point, whatever it is. And then also for tutoring sessions, if you did them in the tutorial center or in the MLC or over here, they have some sort of record that you can bring in, that you can print out and bring in to get your point there. And then if you're in a support course, write support course on it. And then I'll check and make sure you've been going, and I'll give you points for that. Questions about the exam? Everybody good on the whole showing your work thing? I want to know, this times that. Yeah, go ahead.
Sorry, for the exam, do we get the full 2 hours and then you leave when you just finish school?
Yes. Yeah, so it's an hour and 15-minute exam, but I will give you 10 minutes of bonus time. So you'll have 2 hours total, and then whenever you're done, just leave. Mr. Hannon is tutoring right now. Actually, he just finished, so that's not going to help you. But did anybody go over there today for the tutoring? No? I guess I should have emailed you guys. Okay, no worries. Don't forget there's tutoring available. Counting rules. Fundamental principle of counting. Let's see. Alyssa, go ahead and read.
The total number of possible outcomes of a series of decisions is found by multiplying the number of choices for each decision. Example, 2 pants, 3 shirts, 5 shoes, 4 socks. How many possible wardrobe combinations?
Perfect, thank you. So what you should do is write down how many decisions you're making. How many decisions am I making here? 4. So draw 4 dashes. This will make life easier. Get used to that habit. Draw 4 dashes. And then, how many for each one? How many for the first one? 2. For the next one? 3. Next one? 5. Last one? 4. Does that make sense? If you draw the dashes in, it makes things a lot easier because you have to worry about how many of this and how many of that or where I'm going to go. So quiz number 3, call letters of a radio station must have 4 letters. How many decisions am I making? 4. Write it 4 dashes before you even get any further. This is quiz problem number 3. We're jumping around a bit. The first letter has to be a K or a W. How many choices do you have for that first decision? 2. How many letters? There are 26 letters in the alphabet. If I don't put that down on an exam and you need to know, ask me. That's fine. So you cannot reuse letters. So in other words, if you pick K first, you can't pick K again. But you could pick W. If you pick W first, you can't pick W again. But you could pick K. So once you pick a letter for the first one, how many options are there for the second letter? 25. So there's 26 letters in the alphabet. You used one of them for the first spot. So now you have 25 left. Okay, after you pick that one, how many do you have left? 24 for the next option. And the last option? Okay? So this is not a permutation or combination, it's just using some logic, right? Just sort it out. And on the exam, this is what I want to see. And then you put equals. What does it equal? 260. 2760. Okay, good. Factorial, right? It's when you multiply all the numbers from that number on down to 1. So for example, 3 factorial, you start with 3. 3 times 2 times 1. That's the number of ways of arranging 3 items, or n factorial is the number of ways of arranging n items. Because if you have, you 5 people stand up real quick. All right, there's 5 of them. How many options are there for this seat here? I can seat them however I want. 5. Okay, I'm going to pick you. You sit down. Now, how many options are there for this seat? 4. Okay, you sit down. Picking you. Now, how many options are there for this seat? 3. I can put anyone in there, right? You sit down. How many options for that seat? 2. You sit down. How many options are there for that last seat?
1.
Just 1. So 5. See, so that's a number of ways of arranging 5 people into 5 spots, 5 positions. 5 factorial. So it's a number of ways of arranging or arranging that many items. So quiz number 2, how many trophies can be lined up on a shelf? So here's the question. How do I know that it's in order and not any order? You know what I'm saying? Like if order matters. So the question is, remember we talked about, my student said, she thinks of it as if you pick it and you just throw it into a bin and they're all kind of rolling around in there chaotically, then that's a combination. If you pick it and you put it in a specific place or assignment, you go there. You're going to be doing door stuff. You're going to be doing mopping. You're going to be making sandwiches. you assign them a different job or a different task or a specific spot, then order matters. If you're just picking them and they're all rolling around in a bin and they're all mixing and it doesn't matter where they go, then order doesn't matter. It's like what my other student called. She calls that, it's a combination. She calls that chaos. So the normal thing is just a permutation where you put people into spots. The unusual thing is when you have this chaos. They're all moving around in there, and that's when you have to divide by. You have to do the divide by, and you divide by the number of, you divide out the duplicates. So that's the extra step one. This is just the basic one. Here, how many things am I picking? 9. I'm making 9 decisions. Everybody follow that? So it's going to be 9 spots. So draw your lines in first. It makes life easy. How many options for the first one?
9,
Next one?
8,
Next?
7,
Next?
6.
Then 5, then 4, then 3, then 2, then 1. If you draw your spaces in first, then you don't even have to think about when to stop. You just stop when you run out of spaces. It makes things really simple and straightforward. Permutation is when you're not picking all of them. Or you could be picking all of them. It doesn't matter. But order matters. So we have 2 situations. One is when we can reuse items. Right? So like when I'm picking my PIN number on my phone, I can do 0000 for my PIN number. Some of you guys from my math 50 class were like, you told me what a bad PIN number that was. But yeah, I don't care. So you have your thing. I can do 0000 if I want to, right? So that would not be, so you can reuse items. That would just be a regular, ordinary, fundamental accounting principle problem. Or if they're not even from the same group, like pants and shirts and socks. They have nothing to do with each other. So again, you don't need to worry about reusing because they're completely different from each other. But when they're in one giant group and you're choosing from that group without replacing them, like a bunch of students and you're picking a student and you're not going to pick the same student again, or puppies, you're picking a puppy and you're picking another puppy and you can't repick the same puppy, then we're talking about a permutation or a combination. If order matters, in other words, you're putting them in a specific place, then it's a permutation. And really, it's really just a basic fundamental accounting principle. So this is what I kind of think you should use for the formula. Yes, there is a formula, but I think the formula they give you is just confusing and weird and not intuitive. This is logic, right? You should be using logic in your life and getting used to using logic, because then you can figure things out. Life is not about memorizing formulas. It's about applying logic to figure things out. So, permutation. So here, we care about the top 3 finishers. How many things am I picking? 3. Right? So I have R consecutive decreasing numbers, so I'm going to put down 3. R is so here I've got 8P3, for example. So I'm going to have 3 slots here. And I'm going to start with 8. 8, 7, 6. Done. Everybody on board with that part? Good? Those of you who, if you've been using the permutation or combination function in your calculator, you cannot use that. Well, you can use it on the test, but you better write this out or else you're not going to get full credit. I need this to get full credit. Yeah?
Same for factorial?
Same with factorial. Don't just give me 7 factorial. Give me 7 times 6 times 5 times 4 times 3 times 2 times 1. Equals. I mean, you can use your calculator to calculate it, to give me the final answer, but I need to see this on the exam if you want full credit. If you're okay with half credit, then you don't have to do that. But this whole section is about you proving you know how to understand the material, not just pop it into a calculator. After this section, when we get into chapter 5, then you're perfectly welcome to use that function and not show your work. That's totally fine. But for this exam, you have to prove you know where it comes from. Okay, so quiz number 1. How many ways can you arrange the letters in the word decagon? So think of it like, I like to think of refrigerator magnets, right? How many ways can you arrange them? So how many things am I going to be selecting? All of them? There's 7, aren't there? 4, 5, 6, 7. And how many options for the first spot?
7.
Next spot?
6.
Next?
5.
Then 4, then 3, then 2, then 1. What did you guys get for that?
50-40.
50-40. Okay? Sounds good. How many different 4-letter permutations can be made from the letters? In other words, no reusing letters. So how many letters am I selecting? 4. So you should write in 4 slots. Get used to that habit. It will make your life easier. How many options for the first letter?
7.
Next letter?
6.
Next? Next? And then you're done. Stop. Make sense? What if you could reuse letters? So, so how many letters am I picking?
4.
4. If you said 7, that's fine too. I don't care. It doesn't matter. That was a little bit vague. But how many options for the first letter?
7.
And next letter?
7.
Next one? Next? Great. So this is going to be 7 to the 4th. So what were the answers for these?
2401 to the bottom.
2401 and the top one?
840.
840. Good. Everybody all right with those ones? Now we're going to talk a little bit about if order doesn't matter. So remember, that's when you look at these things here, and Alex Ross Rigo is the same as Alex Rigo Ross. It's the same as Rigo Ross Alex. So all 6 of those really only count as 1. And these guys really only count as 1. Oops. These guys really only count as 1. And these guys only count as 1. In other words, order doesn't matter. So here, we have to divide out the duplicates. We have to divide out the number of ways of arranging 3 items. This is the chaos one, right? They're all mixed in here. They don't matter what order they're in, so they all count as the same one. So we're going to divide by r factorial, where r is the number of things we're picking. So this is kind of how I kind of think of it is, right? So the same thing's true. You just find your p, which is this part of up to the numbers, right? This is the p part. And then you add an extra step by dividing by r factorial. So that's the unusual one. When it's chaos, when they're all sort of mixed around and it's a combination, then you just have to have the extra step of dividing by r factorial. So here is an example. So they're picking, let me put in here, order doesn't matter. So if it's something like this where it's kind of unclear whether order matters or not, you can ask me on an exam and I'll either say, oh, I'm sorry, order doesn't matter, right? Or else I'll say, or else I might ask you a question to kind of help you figure it out on your own if I feel like you should be able to figure it out on your own. But this one's kind of kind of fuzzy. So you're an ad executive. You're picking 4 photographs for this flyer. Order doesn't matter. They're just going to go into the flyer. You have 9 to choose from. So this is the unusual one. It's chaos. Order doesn't matter. They're all moving around in there. Is everyone with that part? So how many things am I selecting? 4. So right away, I want to do this. Draw 4 lines. How many options are there for the first one I pick? 9. Next one? Next one? Last one? And see, I'm done. I know when to stop. But because order doesn't matter, and it's kind of chaotic, I need to do the other extra step of dividing by, there's 4 items, 4, 3, 2, 1. So these is kind of, I just match one up for every single one of those are. I just match up a number. But I could have started from here and said 1, 2, 3, 4 if I wanted to, just stop whenever I run out of numbers up there. So that's all you have to do for that one. And then obviously multiply them and divide them. So let's see, 6. I'm going to cancel out those guys. That one too. So 63 times 2, 126. Good. Next, your quiz number 4. So if you did not do number 4 and number 5, I'm going to give you guys a minute and a half to work on those two. Go. Yeah. So the first one, does order matter? You go there, there's 10 videotapes, and you're picking 8 of them. Think about whether it matters where you're taking 8 of them to take home. Does order matter or not? Yeah.
That was my question.
Right.
For number 4, taking number 6.
Right. So you're just choosing 8 videotapes, and you're taking them home. You're just throwing them into your backpack, and you're leaving with them.
So there's no more huge things. I think that's what you do. Yeah. And then I got,
Oh, okay, I see.
yeah. And then 8, so it's 8. Yeah. Wait, no. They're all the same. Right? Just like the sheet before that. I got 2 on 3. No, but this one would keep the same. Because it's each video piece.
Check with your neighbors when you're done. Ria, when you're done, check with Ivana. Ivana, are you done? Check with Ria and see if you guys have. Yeah.
Is this the number you got? The one number? Yeah, I get this one. But this one.
Oh, so you guys done?
Yeah.
Did you check with them?
Does not
Check with them too? Or check with them to make sure that everyone's
Do you want us to simplify that answer? Like to make it smaller for like number 4? I can make it
I do want probably a number at the end.
make that super big.
Yeah, 45, that's right. All right, so let's take a look at what we got. Quiz number 4, does order matter?
No.
No. So this is going to be, how many items do I have?
10.
10, and I'm choosing 8 of them. So I'm going to have 8 slots, 1, 2, 3, 4, 5, 6, 7, 8. And how many options for the first one?
10.
And then 9, and then 8, 7, 6, 5, 4, and 3. Oh, stop there. And then I'm going to divide by, it's chaos, right? So that means I need to divide by more. And I'm going to be lazy. I'll just go 1, 2, 3, 4, 5, 6, 7, 8. Oh, look, stop there. Perfect. And you can either put this into your calculator and get an answer, or you can kind of see how things sort of cancel out a little bit, right? So it really becomes 10 times 9 divided by 2, 45. I need to see those numbers divided by those numbers and the answer. That's what I need to see. Quiz number 5. How many ways can you award first, second, and third from a group of 7 contestants? Does order matter?
Yes.
Yes. First place is different than third place. So this is just a P. So it's 7, and I'm going to pick 3 of them. So 3 slots. How many options for the first slot? Then 210. Good?
Yes.
All right. Quiz number 6. The die is rolled 5 times. Find the probability of getting no 4s. Here's my die. First, find the probability of getting no 4s. So, if I roll it once, what's probably I do get a 4? 1 out of 6. I have 1 4 out of 6 sides. Everybody see that? What's probably I don't get a 4?
1 minus 1 by 6.
Yeah, 5 out of 6. Make sense? Good. I roll it once. I have a 5/6 chance of not getting a 4. I'm going to roll it again. Does the probability change?
No.
No, it's just a die. It's just it's the same one, the same probability. The second time I roll it, there's still 1 4 out of 6 possibilities. So each roll is the same. So the second roll, the first roll, I have a 5/6 chance of not getting a 4. How many times am I rolling it? 5 times. So the second time, what's the probability of not getting a 4?
5 by 6.
The next one?
5 by 6.
So I'm going to do this 5 times. Every one has a chance of not getting a 4. Are you guys on board with me?
Yeah.
So, but I need the first one, and the second one, and the third one, and the fourth one, and the fifth one to all not be 4s. And we multiply. Everyone say, and we multiply. Ready? 1, 2, 3. You really have to know that really well. Literally say it to yourself 10 times when you leave this room. Right? Say it to you 10 times before you go to bed. No. But then say it to yourself 10 times a day for the next 5 days before the exam. So you really get this whole idea. And you multiply. Right? Ors you add. Say that too. Great. So these ands we're going to multiply. And then just pop it into your calculator. You get a decimal. What's the decimal you get?
0.00064.
Is that right? That seems wrong. 0.402. I think it's right. So you must have done 1/6. You guys probably did 1/6 to the right. So all right. So when you round, I believe it becomes 0.402.
Yeah, it is.
Because it's 5 divided by 6, and I'm going to raise that to the 5th power. So yeah, so 0.40187. So really, it rounds to 0.402. If you round it incorrectly and put 0.401, then that's trouble. But hey guys, if you did 5/6 and got 0.833 and then raised that to the 5th power and then got 0.401, then you're fine if you show that step. Like if you had done this, then if you had said equals 0.633 raised to the 5th power equals 0.401, then I would give you full credit. Do you guys see what I'm saying? This is rounded. This rounding gives you a slightly different answer here than if you don't round and you get the answer there. So if you got this because you rounded, if you show me this step, I will not subtract off a point. If you just do this and give me 0.401, then you're gonna lose half a point. Yeah.
So is that 0.833, 5 divided by 6?
No. 0.8 0.833 to the 5th power.
Right, but is the 0.833, is that 5?
No, this is 5/6.
Okay.
Yeah, so 5/6 is 0.833333333. If you rounded that to 0.833, and then said, oh, I'm going to raise that to the 5th, then as long as you write this step in, I'm good with this. Because this is 0.4010, right? But this, with the 5/6, is 0.40187. Okay, everybody on board?
Yep.
Good. At least 1/4. So this is kind of the harder one. I'm going to do this one over again. So this is, we'll assume this is 0.402. At least 1/4. So either I can find the probability of rolling 1 4, probability of rolling 2 4s, probability of rolling 3 4s. But remember, how many ways can I roll 1 4? 4 not, 4 not 4, right? How many ways can I roll 2 4s? 4 4 not 4, 4 4. I can, and then, so I can either find all 7 of those different ways of rolling at least 1 4 and add them up, or I can find the probability of getting no 4s and subtract from 1. So here's what you should do when you do this. So write this, 1 minus the probability of, and then this part right here, at least 1, replace it with none. So none, and then write down whatever comes after. None 4. I know that's bad in English, but just live with it. None 4. So that means none 4 in English would be no 4s. Everybody on board? And do we know no 4s? We found no 4s already. Everybody all right with that part? Good? Okay, this one is super similar, only now I have 22 children. I'm going to pick 3. Can I pick the same kid 3 times?
No.
No. So this is going to be without replaceable, which means that it's going to change, the probability is going to change each time. So it's similar, but it's a little bit different. So let's go ahead and take a break. We'll take a 10-minute break. We'll come back at 9 after. And if you haven't done this one, then try to knock that out. We'll come back at 10 after, but spend at least a minute or two working on trying to figure this one out if you haven't yet.